Good evening. This is Ken Morrow, and tonight's presentation is going to be directed at the mountain pine beetle, or the bark beetle, or the spruce beetle wildfires in Colorado and the correlation between the two. Specifically looking at northwestern Colorado, the area of Red Feather Lakes, and the Cameron Peak fire of 2020. It should be noted that 8 years prior in that same area, the Poudre Valley area, there was also another devastating fire called the Hyde Park fire. So roughly in the last 8 years, there have been two disastrous fires in the area of northwestern Colorado on the Wyoming border. During the 2012 wildfire season, there was also the Black Forest fire and the Hammond fire down west of Colorado Springs, Colorado. Similar terrain, similar issues with the beetle kill that was there. Those fires were said to be human related, where the Cameron Peak fire in 2020 was caused by a lightning strike. So why is this important? That you have to ask yourself when you drive through I-70, I-25, any of the roads in Colorado, or even Wyoming, or currently I-90 in Montana, and you see the orangish discolored trees on the side of a mountain, you are asking what is happening to the forests. The forests are dying at an alarming rate due to beetle kill, which is killing these trees. Thus, the orange color, as you can see, orangish reddish color, and the mortality rate is exceptionally high. People have asked what is causing this. It's basically insects. You could point the finger at climate change, since the weather is changing and the overall temperature trends are increasing on how hot it's getting in those areas, with lack of rain, as well as creating the forests and the natural vegetation to go into a state of being highly stressed. With that stress, it is becoming easier for vectors like the pine beetle, bark beetle to do their damage to these trees. With that being said, our wildfires become more destructive. If you looked at fire perimeters of the Cameron Peak fire or any large fire in the western U.S. and see how they grow through remote sensing data and VIIRS data, MODIS data from NASA showing how a fire grows daily, you could say due to the increased fuel loads, due to their drought-stricken or insect-stricken trees, that the fires are becoming larger and more disastrous due to the fact of the increased fuel loads. The point of the presentation is to present that and highlight that out, just so people can kind of start to understand the severity of what is going on in the forests of the Rocky Mountains currently, and ask the question, is there a future, and what can be done? I said it all comes down to understanding. Not only are the trees dying, due to beetle kill, due to them being stressed, but you have to understand and look at the bigger picture too, is with millions of acres of forest dying, you are also destabilizing an ecosystem. Thus, animals are having to migrate to where there are food sources. Also, with the destabilization of the ecosystem, you are allowing invasive species to move in. So once the trees are gone, you might not have the trees that come back. You might have other vegetation, flora and fauna grow that typically would not be in that area, but due to the lack of seeding of the trees, it's possible that you'd have a completely different ecosystem, land covering. Contradictive is that hey, it takes fires to grow forests because, cones on certain kinds of trees have to get to a certain temperature to drop their seed. But with the destabilization occurring, you're also creating erosion problems, and erosion problems will eventually affect, the surrounding watersheds and people's property, and it's just one problem after another problem when it pertains to the beetle kill and the wildfires in Colorado. Partnerships initially, I had reached out to U.S. at the United States Forest Service Region 2, which is outside of Fort Collins, Colorado. I reached out to the Department of Ag, CSU Forestry Extension, the head forester of Fort Collins, and the head of entomology of the USFS in Washington, D.C. to see if this was a valid concept or ideology. They agreed that it was, but it wasn't warranted for 8 weeks. This is going to be multi-yeared, and they actually wanted to see more research or more concepts of research before they commented. So in the end, I actually ended up having Dr. Bickford look at some of my research to see what he thought. In the future, if this package was put together correctly, then the USFS, BLM, Department of Ag, CSU, places like CSU would benefit from this. Methods, I had to define the study area, which I said earlier was the Red Feathers Lake area at northwestern Colorado. Had to require remote sensing data, Landsat 8, Landsat 9. Could use old imagery from Landsat 5 with the thematic mapper. MODIS data was gathered. NIAP from the Department of Ag was gathered to conduct supervised image classifications. NDMIs, NDVIs, natural burn ratios were created to show what was occurring through satellite imagery of that area. A 3D scene was created showing how there is some new growth going, and then finally there was a dashboard created showing a very small percentage of the area studied and the results that was obtained from that. On the analysis, off to the left we have a supervised classification from NIAP imagery. The natural color, is up in the left corner. NIAP comes from the Department of Ag. It is an aerial flyover of an area. To the right of the natural color is infrared, showing areas in the red are high vegetation areas. The blue, dark blues are water. And then below is the supervised classification of the Red Feather Lakes area, showing water, evergreen trees, deciduous trees, grass, scrub, county roads, forest roads, buildings, and burn. And by examining it, you can see that the classification that was conducted looks very similar to what the natural color and even infrared color shows. Stress vegetation, or NDMI, was done to show the areas of vegetation that was stressed prior to the Cameron Peak fire. Areas in red and orange are showing areas of, extreme stress. Areas in the blue tones are showing that there is adequate moisture content in that vegetation, and in the dark blues is actually showing that is almost waterlogged. So as you can see in the southeast corner of that image, everything is red, and that is showing the most stressed areas. The NDVI, normalized difference vegetation index, on top is basically showing, once again, where vegetation was adequate. The reds and oranges are where there was a lack of vegetation. Yellows was a transition state. The smaller clip below it is showing the same thing. It's using greens, yellows, reds, and blues. The greens and the blues having the best vegetation value, or you could say canopy density. Reds and oranges, lack of vegetation, and yellows are a transitioning state. The The burn severity map was done after the Cameron Peak fire. It is showing the actual burn scar or the extent of the fire. The burn scar is actually the areas in black. Areas in red are showing where there are some vegetation. Areas in black is showing barren, void of vegetation. It can also be due to the fact that it burns so hot in those areas that the ground has been sterilized. We don't know if there's going to be any vegetation that reaccumulates there. Only time will tell. Green, once again, is areas that have adequate vegetation. The bottom analysis imagery was done off of a dashboard design in Arc Pro. It's showing the different kinds of tree types. It's showing the beetle makeup. It is showing how many trees that were observed on a sample. There was 11,000 trees observed in the sample size. And out of 11,000 trees that were observed for the sample size, the tree mortality rate was roughly 71%, around roughly 7,100 trees out of 11,000 died. Not very good. They're in different states of mortality. The results, has the pine beetle increased fuel loads, which have led to more serious fires. At the point it is, skeptical. I mean, you could say yes, due to the increased fuel loads on the ground, that the pine beetle has been, responsible for these fires burning hotter, burning longer, consuming more land. You could also make the case that due to climate change and drought, the same thing could be done, but I could also suggest that with climate change and drought, it's weakening the structures of the trees. So if there is a vector, aka in this example, or an example, the beetle, the pine beetle, bark beetle, the tree's been weakened so much, it's the perfect storm, climate change, drought, and then a vector that comes in and totally decimates a region of forest. There are many references used. I didn't list them all, but a lot of them were based off of, pine beetle, wildfires, wildfire science, NASA imagery, NIAP imagery, different articles on, hey, does pine beetles, contribute to wildfire? Does wildfire clean out pine beetles? Vice versa. But it's just a small little sampling. But this was just a base information that has been presented to hopefully get grant funding or, increase public awareness of what is going on in the Rocky Mountain area right now and why the forests look the way they do. This is Kim Rao. Thank you for your time and have a good night.